Yeah.
when the A is divided by B, it makes the B negative, right? Or am I-
Say it one more time.
When you divide the A by the B, it makes the B negative.
It's not dividing the a by the b. You're dividing y
Okay.
raised to the a divided by y raised to the b. And when you divide numbers with the same base, you subtract their exponents.
Okay.
Remember, it's the same thing as if I were to take 2 to the 5th divided by 2 to the 3rd, that's 1 times 2, or 5 2s.
Yeah.
1 times 3 2s. What's 2 divided by 2?
And then that would be, that would 1.
2 divided by 2?
1 again.
2 divided by 2?
1.
So I'd be left with 2 squared. Notice how I could just subtract those exponents to get it. Here we're just using a variable base, but that rule still works. When you subtract numbers with the same base, when you divide numbers with the same base, you subtract their exponents.
Okay.
Any other questions before we move on? Caroline, McKay, Zay? Zay, do you have 2.6 that you can get it out? You haven't even looked, dude. We were working on it Wednesday and Thursday when you were here. Alright, so let's look at our objectives for 2.6. Then we're hopefully going to wrap up. I couldn't quite remember where y'all wrapped up on Friday with Mr. Lipman, but we will recap a lot of things and figure out where we stopped on Friday, and then we'll work on the rest of the Race Set Go practice, and I will go ahead and let you know. We wrap this up well. We get through all of this. That means you have no homework tonight.
See, I only got 2.5. Maybe last thing will work.
Well, stop losing the stuff I give you. We're working on it Wednesday and Thursday. We worked on it Wednesday and Thursday is my point, when you said you were here.
Probably left it in here. I did it
Possibly.
Friday.
Alan, can you read our first objective for us?
I can work with the properties of exponents.
Homework was on that. Hopefully we know our properties of exponents because we're going to extend those a little bit. Anthony, can you read our second objective for us? So we've been talking about that pretty heavily. We need to get comfortable with it for sure. Just as a heads up, these ideas of properties of exponents and connecting rational exponents to the roots of numbers, you'll have an understanding check on Thursday for that. So we just need to be aware, working towards that. Gavin, we may have to take yours on Wednesday since you probably won't be here Thursday, right?
I won't be here Thursday.
Right. So we'll have to take yours on Wednesday. Mona, can you please read our last objective for us?
I can extend the properties of exponents to rational exponents.
So these rational exponents that we're talking about here, the properties of exponents that we're talking about here, we're combining them into this last objective. So this is the first part of 2.6, and please understand I am going to do a quicker review because this will be the third time that we looked at these ideas. But where Carlos said that he deposited $300 with 5% annual interest, and so he went from $300 to $315. How did he get that $315 from that 5% interest? Caroline, McKay, let's talk about it. Engage with the ideas. Where's your work?
I don't know, that's what I'm confused about, because I remember putting this work on my page when they were.
Did you check to see if you have a second copy of this?
Possibly, that's what I was just thinking.
Yeah.
I looked at it like, that was dumb.
Somebody, come on. We have talked about this way too many times for no one to be able to respond and say, hey, this is how we got from 300 to 315. Say it again, Gavin.
I know how we did, I just gotta write it down.
Okay. Well, what did we do, McKay?
Multiplied 1.05.
All right. If it is a 5% interest, remember we always start at 100%, and then we're increasing this time by 5% for 105%. So multiplying by 1.05. 300 times 1.05 is how we get this 315. So what did we have to do to get each of these values for each month?
Split 1.05 20 times, 12 times.
We multiply by 1.05 12 whole times.
Split it.
split it 12 times. How do we split up that common ratio is 12 times?
Fraction.
Close. When you say a fraction, what do you mean?
9/12, 2/12, 3/12.
Well, 1/12, 2/12, that's just the inputs though, not a square root.
That thing, whatever it's called.
Which root is it?
That thing, yeah.
Which
Twelve
root?
root.
12th root, right? We looked at a 12th root. The idea being that if we multiply or some common factor 12 times, we get 1.05. Well, then what's the inverse of a 12th power? A 12th root, right? So we knew that the common factor, a constant factor, had to be the 12th root of 1.05. We also talked about the fact that instead of doing it as a 12th root, you could just raise it to the 1/12. Because when you raise power to a power, you multiply them, so f would just be 1.05 to the 1/12. All those ideas were important. We explained all of them, we're good to go, right? Okay, again, there's work down here. Please remember, all of these solutions, we're finishing up 2.6 today. Tonight, 2.6 with the solutions will be on Schoology. So you can get those later if you need to, if you missed today or anything like that. So, number 3 here asked us to verify that both equations give the same results, these two equations here. Using properties of exponents, explain why these two equations are equivalent. And so we explained why the two equations were equivalent by showing the work, because when we raise a power to a power, what do? Multiply, right? So the 12s canceled, leaving a 1, and so we're left with 300 times 1.05 to the t, which is what we started with.
Yep.
But I do want to always remind you, is algebra the only mathematical representation available? What else do we have?
Isn't there like
Geometry.
sure,
There's pictorial, graphical, verbal, tabular, and then this algebraic, right? A very simple and quick thing that you can do is just graph them. Notice, here I have the blue and the red mapped on top of each other, but you only see one graph, because these two things are what?
equivalent.
Equivalent, right? They give the same results. They look different, but they are effectively the same. We go with those ideas. Alright, and so then what did the 12t in this equation mean?
A year.
Well, it is 1 year, but 1 year's worth of what?
12 months.
There's 12 months in a year, right? So if there are 2 years, that'd be 24 months. 3 years would be 36 months, right? Because we looked at this. This is not the yearly factor, this is the monthly factor. So I had to raise it to a monthly, or to a number of months. Okay? And I believe you talked about this number 5 with Mr. Liplum, right? What was this 1.004 meaning?
0.4% monthly rate.
The monthly rate, remember this 1.004 came from the 1.05 raised to the 1/12, right? So it was the monthly constant factor, right? So earning 0.4% interest monthly. How did we get to 0.004 from 1.004?
We moved to this.
Added 100.
So we moved the decimal, right? We made it a percent, which would be 100.4%. But what do you always start with?
100.
You always start with 100%. So what was the percent increase? 0.4% or 0.004. So I want you to notice those connections, right? This 1 right here is the 100% that you started with. You don't need that anymore. What is the percent interest, right? What is the percent increase? Whew, that was a lot. This, I know, is where I remember y'all finishing or working on a lot. Did we all finish these numbers 6 through 11? No.
10 and 11.
10 and 11 left?
I got 11 left.
You got 11 left? Y'all are almost done, right?
11.
11 left. Alright, so let's take about 5 to 10 minutes. Let's wrap up as much of this as we can. I will look at what you have going to direct the conversations that we have. But let's continue to work through it. Do not forget, you need to also explain what these different things mean, okay?
Question.
Yes, sir.
I believe that might be mandatory.
It doesn't matter. Honestly, if you want, I would jump into one of these other two groups so you can have conversations with people.
I'd rather with the group I had, honestly, because that was a pretty good discussion.
It was.